Okay, so let's start with MCQ number 9 of this paper, which is the paper 1. Okay, the question says the aqueous hydrogen peroxide decomposes into water and oxygen in the presence of suitable catalyst. And if you have studied the biology of O levels or A levels, you must know that our body has an enzyme which is going to decompose it because it's not good for our body. So the formation of this one is going to be again, sorry, this compound is going to be decomposed by our body naturally and catalyzes the enzyme. So yes, we need catalyst. Okay, let's say the 50 cubic centimeter of 0.5 mole per cubic decimeter solution of hydrogen peroxide produced 120 cubic centimeter of oxygen in 2 minutes. The volume of the gas was measured at room temperature. What is the average rate of decomposition of hydrogen peroxide during this 2-minute period? Okay, let's find its the concentration first, because we have a volume and we have mole. So we can simply go for the concentration one. And the next one is sorry, when we calculate the rate, so we'll check the decrease in the rate, and it will give us a value. Okay, let's say. So first of all, let's put a formula of concentration, or sorry, concentration is there, we need to calculate the moles, sorry. So moles is equal to the volume divided by concentration. Okay, so our volume is in cubic centimeter. Let's convert it into cubic decimeter. The volume would of this one would be 0.005. Sorry, it will be 0.005, correct. And the volume here would be 0.120 cubic decimeter. Okay, so let's find, first of all, let's find the change. The change, okay, if it's a gas, then we have to convert it into moles. And how to convert a gas into moles? We use a simple formula that moles is equal to the given volume, and if it's cubic decimeter, we divide it with 24. Even though we can even divide it with 24,000 in cubic centimeters, the answer would be same, but it's better to convert it into the standard units. Okay, so 0.120 divided by 24 is 0 point, so the moles of oxygen are, sorry, 0.005. Okay, let's say how many moles are we getting for from this two hydrogen peroxide, which decompose into water and oxygen. So we, let's write the standard, sorry, the balanced chemical equation. It would be 2H2O2 gives 2H2O plus O2. Okay, so the ratio is basically 2:1. Let's say 2:1. So if there are 2 moles of hydrogen peroxide, we are going to double it. We just multiply it with 2. So answer would be 0.010 moles of oxygen. Okay, so now we are going to calculate it, or we are going to calculate the rate of reaction. So it would be 2 minutes. Let's convert it into seconds because they have asked us about the units in seconds. So 2 minutes would be equal to 120 seconds. Okay, now we have time, we have more. Let's talk about the volume. The volume is 50 cubic centimeter, so it will become 0 0.050, not 0.005. So I'm wrong. It would become 0.05. So let's calculate the rate. The rate is equal to uh, let's talk about the oh, moles of oxygen, which are 0. Sorry, 0.010 divided by the volume, which one is, because next thing is volume. Volume is 0.005. 0.05, and then a second multiplied by 120. So our answer turns out to be 0.0017. So this would be our answer. Next question is, the average intermolecular force in water are much stronger than the intermolecular forces in steam. Okay, the liquid one is definitely going to have a stronger bond because the kinetic energy is lesser. Because in steam, the kinetic energy is very high, the molecules tend to move really fast, and the intermolecular forces tends to break. The average intermolecular force of in ice are slightly stronger than average intermolecular forces in water. Enthalpy changes are associated with the equilibrium process are shown. So we have for boiling and we have for melting. Which statements are correct? Okay, let's say delta HP and delta HM, the enthalpy for boiling and melting, are both negative. Delta HB is greater than delta HM, and the intermolecular forces in ice and water are of same types. Let's say third one is correct for sure, because the intermolecular forces are not going to change because the molecule is same, so intermolecular forces would be correct. So the next question, sorry, the next statement, let's say which one is correct. Okay, one is the exothermic process and one is the endothermic process. So when we talk about boiling and melting, um they are actually okay. Delta H, they are actually negative statement. Like, okay, delta HB is greater than delta HM. Okay, in melting, we need lesser force to, because the bonds are in the right position, the distance only increases. But in boiling, the kinetic energy is so high that their bonds might break. So delta HB is greater than delta HM. So these two statements are correct. Next one is 11th one. An experiment is carried out to determine the value of X in hydrated lithium hydroxide. Okay, so here is given hydrated lithium oxide hydroxide. Sorry, a sample of solid is heated in a crucible over a Bunsen flame. Complete dehydration take place, decomposition does not occur. Mass of the crucible, empty crucible, is Q. The mass of the hydroxide along with hydrated one is R. The mass of crucible after residue is this. What is the what which equation give us the correct value? Let's say, so we have R minus, okay, the residue after heating. So we have hydroxide. So the mass of the crucible, it would be R minus S for very sure. And then we have the mass of empty crucible, and we calculate the residue. The residue would be S minus Q. Okay, this one is a hydrated one, and this one is the residue. This is a residue, and we minus the value of what do we say? The crucible. Okay, so what we need here is their mass. The mass of water is 18, so here we have 18, and the mass of lithium hydroxide would be, lithium is 7, and then 1 8 8 and 16 is 24. Okay, it would be 23.9. So our answer would be C.